Friends, today we are going to discuss the component of cooling towers, component used in cooling tower. The basic component of an evaporating tower are the frame and casing. This is frame, this one is the frame and casing. These are the other casing. Frame and casing, fields, cold water basin, drift eliminators, air inlet, lowers, nozzles and fan. Frame and casing. First of all is the frame and casing. The most towers have structural frame that support the exterior enclosure, that is called casing, motor, fans and other component. So frame and casing, they are structure, they are enclosure, they are supporting motor, fan and other components. With some smaller design such as some glass fiber unit, the casing may essentially be the frame. Here casing, the smaller component, casing is itself is the frame. Otherwise frame will be different, casing will be different. uh, Frame. Then fields. Most towers employ fields made of plastic or wood. It may be fields may be plastic and wood to facilitate heat transfer by maximizing water and air contact. Water and if you are using fields, then that will increase the time for mixing the water with air. Field can either be splash or film type. We'll discuss one by one. With flash fields, water fall over successive layers of horizontal splash bars, continuously breaking into smaller droplets, which also wetting the field surface. Also wetting the field surface. So these are the horizontal splash bar where continuously water will drop, and that drop when come in contact with the horizontal splash bar, it will breaks, breaks it will breaks, and that will promote better heat transfer than the wood flash fields. Plastic flash fields promote better heat transfer than the wood flash fields. If you compare the wood flash field with plastic flash field give you the better performance. Then film field consists of thin, closely spaced plastic surface over which the water spreads, forming thin film in contact with the air. Forming a thin film in contact with the air. These surface may be flat, corrugated, honeycomb, or other pattern. The surfaces are maybe flat type or corrugated type or honeycomb type. The film type, the fields is the more efficient and provide same heat transfer in the smaller volume than the flash field, because flash field, the film are more compact, that's why area is more, that's why it compared to splash field, it is more heat transfer will take place. Then cool water basin. The cool water basin located at the bottom of the tower receive the cooled water and flow down through the tower and field. Flow down to the basin usually has a sump. This basin have a sump at the lower point where the cold water will discharge connection will be there, and through pump it will go back to industry again. Then you see, this is the splash type fields. This is the horizontal bar. When water will fall, on the flash bar, it will breaks and small pieces and air, so that air contact will be more. And here it is the film type. You see different configurations are there. It is honeycomb. It is a honeycomb type. Here area will be so much. The corrugated sheets are there. So area of contact will be more than this one. It is compact, this more this one, and heat transfer will be here more in film field. Now the differences. The splash field consists of layers of horizontal bar and slats that you have seen. Horizontal bar and slats horizontal bar and slats. When the warm water heat the surface of these bars, it spreads, breaks, and form smaller droplet. When the water will come in contact, drop on this bar, it will break and form smaller droplets. As more droplets are formed, like more droplets are formed, there is increase in contact between air and water. So it will break and lot of droplets are there. Then air and water connection will be contact will be more, and which accelerate the rate of cooling and evaporation. Therefore, rate of cooling and evaporation will be more. Flash film media were traditionally made of wood. It can be made of wood also. It can, but modern design make with the use of PVC. PVC is more efficient as it facilitates better heat transfer. Better heat transfer will take place compared to wood. Glassine is ideal for use in industry which generate poor quality of dirty water. Some dirty water also it can tolerate because it is a not contact design, it is not compact design. Tolerate, so it will not stick there. As the water is broken up to form small droplet, there is no medium in which dirt and debris can caught and trapped. So when the water small droplets it broken into small tablet, so debris and dust cannot be caught and trapped. Therefore, the efficiency of the medium is not reduced. So, if the dust is there, then also it will not reduce. The performance will remain same. The film consists of closely packed thin sheets of PVC material with a flat. So PVC sheet plus flat will be there. Corrugated and otherwise texture surface. Texture means up and down surface. It creates a large surface area on which the hot circulated water spread, forming a thin film in contact with air. This allows heat to evaporate and accelerate the rate and cools the water faster. So as the area is high, there will be area is more and gap is less. So they will form a film, and when water it will come in contact with the water, come with the air, it allow heat transfer accurately. Film is ideal for but ideal for cooling clean and quality water. If water has having debris or solid particle, then it will choke the between the plates. So and there will be no flow. Flow will be reduced, and not only that, the heat transfer will also be reduced. Debris in the water can build up in the film media and reduces this efficiency. Huh? So film though it is better having better surface area heat transfer, but water quality should be very clean. You see now the other parts. This is the drift eliminator. You see, this is the drift eliminator. Drift eliminator, it capture water droplet entrapped in the air stream that otherwise would be lost to atmosphere. When air is coming out from the induced draft fan, it will take some water droplet along with him. But when the water pass through this corrugated this circular path due to circular motion, the heavier particle like water, centrifugal fluid will be more, so it will fall down and only air will pass through it. These are the different shapes of the louvers of the dipped eliminator. So if dipped eliminator is there, your evaporation loss, water loss will be reduced. Air intake. These are different types. There are honeycomb type, different types of deep eliminators are there. When air will pass through this, and there will be a circular motion. Radius is there, so higher particle will come down, and only light air will pass out. Pass out. Then air intake, there is this is the point of entry for air entering the tower. The inlet may take up an entire side of the tower, cross flow design, and to be located low on the side of the bottom of the counter flow design. So if it is a cross flow design, the entire side of the tower will be air intake will be there, and if it is the counter flow, then it is at the bottom. If you see the drawing design, you see this is the cross flow. Here entire portion, you see the entire portion air flow will be there, and this is the at the end, this is the drift eliminator. When water will pass through, air will pass through this, the some droplets are will be there, but due to circular centrifugal motion, the water will fall down, only air will go. Similarly, if it is a counter flow, then you see at the above above this nozzle, there is a drift eliminator is there. When air will pass through this drift eliminator, water will, has to pass to the zigzag path, and then air will pass to the zigzag path, and the heavier particle water will fall down, only air will go. So this is the lower, this is the drift eliminator, this is the different location. This is in the cross flow, it is located at the center, at the periphery, and counter flow, it is at the top. And then for lowers, for cross flow, it is entire width, height and width, and for the counter flow, it is at the lowers are at the bottom. Lowers are situated at the bottom, at the bottom. Then lowers, then nozzles. You see the nozzle, they provide the water spray to wet film. They will provide the water to flow through this nozzle, and the upon where now on the wet to wet the fill, or the fill to make the fill wetted. Nozzle can be either a fixed, either be fixed in the place and have either round and square spray pattern, or can be a part of the rotating assembly as found in some circular cross-section lowers. So you see if you see the drawing, you see this is the fixed type. When water will flow from the bottom, it is actually vertically downwards. So when water will flow, it is fixed in the deck. When water will flow, it will drop here, and it will be sprayed like this. And it is square type. Mounting is square type. So here is also water will. There are two types, and another one type is it is rotating. It is rotating. So different types of nozzles are available. Different type of nozzles are available as per design requirement. You have to select. Then fans. This is the fans. This is the for FD FD fan. It can be popular fan. This is the popular type. This is the centrifugal type. So FD fan can be popular type, can be centrifugal type, but in the induced draft fan, it will be simply popular type. This type of blades, centrifugal type of blades, are not used for ID fan, but FD fan, it can be used either this or this, either this or that. The next is lowers position. I have already discussed throughout the width, throughout the height, and for cross flow and for counter flow, it is at the bottom. Then nozzles also we have discussed. This is the deep eliminator location I have already discussed. And then deep eliminator, deep eliminator are designed to capture the large water droplet caught in the cooling tower air stream. When air stream, it is there on the air stream, when it pass through this deep eliminator will caught it. This type of this eliminator is there, this will caught the water column, eliminates the prevent water droplets and mist from the escaping to the cooling tower. And here the A type of cooling tower, concrete natural cooling tower. This one shape. The shape of this is hyperboloid, or sometimes it is incorrectly known as hyperbolic. This shape is hyperbolic. Cooling tower have become the design standard for all natural cooling tower because of their structural strength. The structural strength will be more. Structural strength, if it is cylindrical, then structural strength will not be so much. So if it is a circular type, parabolic type, the circular strength will be more, and minimum use of material, and the hyperbolic shape also aid when it pass, air will pass through it due to convergent divergent nozzle. Your air velocity will be much more high, and efficiency of the cooling system will be high. Then what how material of construction related to drip eliminator. Drip eliminator material or your film material are normally we have to either PVC, polyvinyl chloride, or polypropylene PP. Both type of material are used, but they are having the this property of high hydrophobic. Hydrophobic means the having the property hydrophobic means the property of a substance that repels water. It repels the water. It will not absorb the water. It will repels the water, and then water will droplets will be there. It will not stick to the surface. So it will mix with the air properly. Properly. So PVC and PP are high enough and make it beat up to form into shape of a droplets. uh, droplets. Unfortunately, this action is detrimental to the performance of films and drip eliminator, which achieve their full potential when water fully weights the polymer surface. The polymer surface. So one is a very important property they are having, that is called hydrophobic. It is not sticky to the surface. It repels the surface will repel the water. That's why PVC and PP are used. And that's why if you use this one, then water droplets, no water will pass through the mist eliminator, and it will not stick to the hills. So evaporator losses will be very difficult losses. Nowadays, most of the end users specify call for 0.02 drip losses, but if you are using PVC, the drip losses can be brought down to 0.003 to 0.001% also possible. Now this is the return header. You see, earlier design, the return header was on the top of the deck, but due to its weight, sometimes the cooling tower collapse. Sometimes the cooling tower, we have seen so many cooling tower collapse due to the weight of the downcomer, weight of the riser, weight of the return header. It is coming from the plant, and it is hot water coming from the plant, both side, and it is giving, it is a cross flow type. Both side air entry is there. These are lowers. So due to it is full of water. So from here it will through the nozzle, through the butterfly valve, deck valve, it is basins are there. Their water supply will be there. It is gradually bring down the diameter so that equal distribution will be there. But it weight is very much. That's why what happened now we have to sometime with cooling tower we have found the collapse. That's why nowadays this return header we kept at the bottom, and from here we are taking the branches. You see, this is the taking the branches, and from the branches T, and it will be distributed to the individual basin. In how many basin? 1, 2, 3, 4, 5, 6, 7. Whatever towers is there, like these basins will be there. There water will be uniformly distributed. Water will be uniformly distributed. And the weight is outside. The outside, this is the structure. It will hold this axial radial movement, and there is no weight of this pipe will come on the peak. This is the modification nowadays has carried out to previous over the previous design. This is the blade. This is your blade of the cooling tower fan, induced draft fan blade. And these blades, you see, this blade is having some angles. It is moving in that direction, and it is moving. The blade, the profile is like this. So it is this angle is called the pitch angle. If you increase the angle, your flow will increase. If you decrease the angle, your flow will reduce. But if you increase the angle too much, then lot of turbulence will be there. there, and if you decrease it to the too small, then your to be reduces motor load. Of course, if it reduces motor load, save some energy. However, if too low, if the angle is too low, then what will happen? The system will take longer time to reach the cooling tower target. Normally, the angle remains between 10 to 18 degree. It can be turned to 45 degree, but it is normally we used to keep in between 10 to 18 degree. And what we are using now, we are using a bevel protector. Put it here and measure its angles, and then all the blades we are there is a clamp system is there. With the clamp you can rotate these blades, and all the blades you will have the same angle. Normally what we are doing during hot cooling water, cooling air flow is much more is required. At that time we increase the angle, and when it is in the season of winter, there is no need of so much air flow. At that time we reduces the angle, and like this we are saving some energy. And earlier the blade material was GRP, solid glass filled SGL glass filled glass filled material. The weight was more. Nowadays hollow blades are available, which is lighter in weight, so your power consumption of the motor will be reduced. Now more or less every for cooling tower are using hollow type blades. Earlier it was solid type blades. Now due to heavy weight, power consumption was more. Now the blades become hollow, and weights become less, and performance become more or less same. Then that's why the vibration as well as the motor consumption will come down. And this in some cooling tower, this blade pitch angle will can be varied with variable pitch angle. From the outside there is a servo motor is there, and if your if your air requirement is less, automatically they will sense the pressure and then reduces the angle. So like this you can save some energy if you are using variable pitch angle induced draft fan. You see the curvature is there. You see the volumetric flow is 10. If you increase the angle 15, the volumetric flow is going to increase. Volumetric are going to increase, but power flow is also going to increase. So normally we used to keep 15 to 18, in between 15 to 18, so that you will get the required air flow. Cooling will be perfect. So friends, I think I have discussed the in this post the different items used in cooling tower, like frame, casing, then your nozzles, fill material, flash fill, film fill, then your fan and gearboxes, etc. And how increase the fan and pitch angle will increase the airflow, and if you decrease the pitch angle, your airflow will come down. But too much airflow, there will be turbulence will be there. If too low airflow, you will take long time to reach to your target cooling tower target. These are the basic material which we have to use for every cooling tower fan. So I think if you go through these slides, your whole concept will be clear, uh, and will be clear. And if you are satisfied with these slides, please give a tick mark, and subscribe this channel, so that in next post I am going to tell you the parameters of cooling tower, and so many other posts will also going to come that will be helpful to you. If you are satisfied, then you share this channel to your friends, particularly those who are final year graduation training mechanical engineering, those who are already admitted in the graduate engineer in the industry. And if you are having you will get a very good knowledge that will help you to understand the purpose and how to do the maintenance practical approach I have discussed. So I think if your all concept will be clear, and if you still have doubt, you can or telephone me or mail me, and you can convince your management also to arrange a video conference with mutual agreement, so that if you have any doubt, that can also be clear. Thank you very much.